Okay, this just is going to be a short presentation over sort of the end of Unit 2, and I'm going to present some things that we didn't get a chance to discuss in class, so please take some time to look over the video and answer the questions that I'll provide in the assignment I'll send you shortly. So where we ended up was discussing the 5 laws of resource use. Number 1, old resources become expensive, the search for replacements begin, and tech responds. Number 2, changes in resource use create new geographies, and I'll give some examples here in a minute, of literal landscapes, politics, sense of place, and network relations. Number 3, social and political consequences, both local and global scales. Number 4, public-private tensions between resource users. And then finally, 5, regulation debates on negative consequences of resource use. So the example that we used in class was coal. Coal is a pretty easy example to discuss, and so I'm going to look over that here in just some more detail. So as we discuss this in detail with the 5 laws of resource use, there are some interesting sort of connections there between those 5 laws and coal. So beginning in the 17th century, Britain had overused wood and timber as a heating and power resource. So much so that much of their forested countryside had become barren. As timber became scarce, energy prices soared. Britain began its search for new alternative energy sources. So the construction of the first coal mine in 1575 by Sir George Bruce would eventually lead to an industrial revolution some 200 years later. Coal was first extracted close to urban settlements where it was consumed. Now, once that source became scarce, speculators began to search for new sources of coal further from the market. Now, this was the catalyst for the development of train technology. Ironically, it would be the demand for coal which would lead to the development of coal-powered trains. So if we go back to the previous slide, we can sort of compare these, the transformation from timber to coal, and look at the 5 laws of resource use. As we discussed in class, timber had become scarce, and Britain needed a new source of energy. A new source was extracted in 1575, and by the late 1600s, coal had become a major source of energy in Britain. By the early 1700s, coal mines not only located near major cities, but dotted the landscape throughout Britain. It had created new geographies of literal landscapes, politics, sense of place, and network relations. For example, mines had literally changed the landscape by digging up formerly fertile farmland. The burning of coal also led to the rise of heavy pollutants such as sulfuric acid and carbon monoxide. It created new political landscapes as town councils and cities began competing for control of the resource. New cities popped up to house mine workers and their families. Now, the coal mining town became a staple of rural Britain and the United States. This created a new sense of place. Communities felt tied to the land that had created this abundant resource. It also resulted in the creation of functional regions based on connections of towns and cities by the railroad. A new network of relationships developed based on the new power source. Now, with the new resource in full use, coal usage resulted in both social and political consequences on a local and global scale. The Industrial Revolution occurred because of this new resource, and a new social class of industrialists used their newly acquired wealth to squash any potential competition. Many people moved from rural farming communities to central cities to work, both because of the promise of wealth and government policy. One example is the enclosure system in Britain that forced small farmers off of their land into cities. There was also a significant rise in localized pollution, which would later result in global pollutants that don't adhere to borders. After coal became a major commodity, there were growing tensions between public entities and private corporations over who actually controls a new resource. For example, in 1902, a coal strike over wages and safety inadequacies in an anthracite coal mine in Pennsylvania resulted in the intervention of government regulators during the Teddy Roosevelt administration. Now, while this example is not directly about the control over coal itself, it presents a great example of public-private tensions over the extraction of the resource. While private companies continue to control the resource, the Anthracite Coal Strike Commission was created to oversee arbitration over worker pay and safety measures taken by the anthracite coal industry. Now, this would mark the beginning of a long collaborative relationship between the natural resource extraction industry and the United States government. Now, the tension between public institutions and private companies resulted in debate between academics and government authorities over the negative consequences of coal usage. In the United States, major regulatory measures on labor conditions in the coal industry began under the Franklin Roosevelt or the FDR administration in the 1930s. The Guffey Coal Act of 1935 imposed price controls and various labor regulations on the industry. The Department of the Interior imposed new mine safety standards in 1946, and those were codified into law in 1952. Now, since 1985, coal, like oil, has not been subject to explicit economic regulations. Instead, coal regulatory efforts have been environmental in nature regarding the pollution from its use rather than the economics of its production. So this slide gives us some examples of how natural resource use leads to new geographic landscapes. Now, the Chuki or Chuki Kamada copper mine is located in northern Chile and is the largest open pit copper mine by excavated volume in the world. This is an example of a literal landscape created by resource use. This mine was built by the Chile Exploration Company and the Guggenheim Group in 1915 and has remained a major source of copper for the region since then. And the picture on the bottom left here, it was taken in 2017 and shows a group of Sioux Native American protesters at the Dakota Access Pipeline construction site in Standing Rock, North Dakota. Now, the pipeline itself created a literal landscape of above-ground pipes that can cut through farmland owned by the Sioux tribe of Standing Rock. It also transformed the sense of place felt by the local population. According to a court filing by the Sioux tribe, quote, "There is a high risk that culturally and historically significant sites will be damaged or destroyed if the pipeline is completed." The pipeline resulted in political pressures from the Sioux and several advocacy groups around the U.S. Now, this map on the upper right shows planned oil and natural gas pipelines in the Middle East through Syria. The blue line here was drawn by the Obama administration in 2009 and proposed to Bashar al-Assad, the president of Syria. Now, Russia suggested this red line over here. Assad eventually accepted the terms from Russia and not the United States. Shortly after that, conflict arose in the region between the U.S. and Syria. Oil has become a staple of U.S. control in the Middle East, and the U.S. government could not allow this project to go through. So it created new political landscapes. Now, the picture on the bottom right here shows the resulting oil spill from Deepwater Horizon in the Gulf of Mexico. A series of regulatory oversight failures by the U.S. government led to a massive explosion and the leaking of approximately 4.9 million barrels of oil into the Gulf. The result was the death of marine life and the destruction of coastal environments in several southern Gulf states. Debates opened on the quality of regulations on offshore oil platforms, and the National Commission on the BP Deepwater Horizon oil spill and offshore drilling was created to investigate future regulatory measures. Okay, so I'm going to skip ahead. Like resources and food, population is interconnected with the environment in many important ways. As with food and resources, there is a stronger link between economic development and environmental degradation than there is with population growth. Now, the Kuznets curve, shown here on the right, attempts to explain this relationship. Of course, it fails in some very important ways, which we'll discuss here in just a second. Now, the environmental Kuznets curve is based on the Simon Kuznets curve, i.e. that as wealth increases, inequality increases and then curves back down. Now, the Environmental Kuznets Curve was first proposed by Gene Grossman and Paul Kruger in 1991. Now, the theory argues that there are four main stages in economic growth and pollution. Now, you can see these four stations numbered here on the graph. Now, as a country moves from stage 1 of development to stage 3, pollution grows arithmetically until it plateaus in stage 3. As a country becomes wealthier, moves from 3 to 4, they can then now afford to institute environmental regulations. As a result, pollution declines arithmetically during stage 4, as you can see here. Now, from a very simplistic view, the Kuznets curve can suggest that economic growth is good for the environment. However, critics argue there is no guarantee that economic growth will lead to improved environment. In fact, the opposite is often the case. At least it requires a very targeted policy and attitudes to make sure that economic growth is compatible with improving in the environment. One of the biggest critiques is that the Kuznets curve is inconsistent with empirical models. In other words, the data does not prove the model correct. As you can see from the simplified model on the top right over here, as a country moves from more industrialized, as a country becomes more industrialized, it should grow in pollution, then decline as it enters sort of a post-industrial period, making this upside down U shape. However, this graph on the bottom right suggests that there's no decline in emissions as a country becomes wealthier. So you have GDP per capita down here, and you have CO2 emissions here. It suggests that actually it plateaus as you get wealthier, not declines. So let's take a look at the Gapminder website directly and see if we can get a better view of this. So let's take a look at this graph. So this is the graph essentially that's shown on the slide. And as you can see, as we move from GDP, as we move from more developed, or from lesser developed to more developed, so here's Luxembourg, and then here's the Democratic Republic of the Congo. As a country becomes wealthier, notice that in the early stages of development, there's a massive increase in CO2 emissions. But as we reach a plateau, which is around where China is right now at 15.2 thousand GDP per capita, so the average person produces about $15,200 worth of goods in a year, then there's this plateau. And notice that it stays relatively the same. So here we have 15.9, 7.06. There is this plateauing effect. Does not suggest that there's an actual decline. And we can actually go back in time and we can see how this has changed. So even if we look at China specifically over time, you notice as it becomes more developed, it does plateau. We can even look at Brazil and compare the two. Both of them have similar sort of trajectories. As they become more developed, they then plateau at a certain height. So like I've stated before, it doesn't really follow the empirical evidence. So it lends to the question that where in the world did Paul Krugman get this theory from? Now, other critics have argued that the total pollution doesn't actually decline. It just gets outsourced. So instead of pollution declining in country A and disappearing, what it actually does is gets transferred to country B that's actually doing the industrial production. Other scholars have criticized the model because it doesn't include non-air pollutants such as poisonous runoff into rivers. And this remains quite high in developed countries. Others argue that the scale should not be national because pollution doesn't adhere to borders, so we should really think about it from a global perspective. And finally, some scholars argue that it should be an N shape rather than an upside down U. Of course, that doesn't really follow the empirical evidence either. So just you have to remember that the Kuznets curve is an important model, but like all models, it does not really explain things perfectly, and it should be taken with a grain of salt. Now, while the Kuznets curve attempts to explain the relationship between economic development and pollution, it does not really tell us how people impact their environment directly. Major ways that we negatively impact our environment include deforestation through the removal of large tracts of forest for agriculture, desertification caused by poor farming practices, concrete surfaces, i.e. impervious surfaces, which result in the urban heat island effect, where temperatures are significantly higher in urban areas than in rural areas. The pollution of fine particulate matter, such as aluminum sulfate, sulfur dioxide, barium, strontium, carbon monoxide, etc. And finally, the dumping of plastics and poisonous materials into the ocean, rivers, and groundwater. Now, this includes oil, glyphosate, pesticides, and even snow salt. Interestingly, snow salt actually has a deadly amount of arsenic, and once it's put on roadways, after it melts the snows, it runs off into the local streams and can lead to the death of aquatic life. The most famous example of deforestation is the removal of vast swaths of trees in the Amazon rainforest of Brazil. Now, this is not a new phenomenon and has been happening since the arrival of Western corporations into the jungle. The biggest cause of deforestation is not logging or anything like that, but transnational corporate cattle ranching and soybean production. So let's take a look at this NPR article about the recent deforestation in the Amazon. According to the article, Amazon rainforest sees biggest spike in deforestation in over a decade. Picture for a second just how vast New York City is. All told, including Staten Island, the Bronx, and every block in between, the massive metropolis takes up more than 300 square miles. Now try to picture a hunk of land more than 12 times that size. That's about how much the Amazon rainforest was destroyed in just the span of a year, according to the Brazilian authorities. The country's National Institute for Space Research, or INPE, released data Monday revealing that 3,769 square miles of rainforest were lost to deforestation in a 12-month period ending in July. That marks the highest rate of deforestation since 2008 and a nearly 30% spike over the rate recorded by INPE during the previous year-long span. Now, this is due largely to cattle ranching and large farming practices, not by local farmers, but by large agribusiness. So, against common thought, this is not the small farmer, this is not logging, this is big agribusiness that has led to much of this destruction. Now, this other article that I've got here on the slide from the New York Times is pretty interesting. It's got, the article is rather short, but it's got several maps that you can look at. So this shows in the green the existing forest. This shows deforestation through 2018. In the yellow, and then red were the fires in August of 2019. And you can see over years and over time, over the season, throughout the seasons and years, the amount of destruction of rainforest. Now the fact is, now these are fires by month. The fact is that fires are normal. It's a normal occurrence in the Amazon. It's been happening for decades, and it happens at its height in August, September, and October. But that does not mean that it's not getting worse in many ways. So some of these fires are natural. In fact, most of them are natural fires, but many are also fires that are used during slash and burn agriculture as well. So that should be kept in mind. If you want to take a minute to look at this link, it's on the slide. It's an interesting article, and it is free. There's no membership charge for this particular article. All right, so Brazil gets most of the news about rainforest deforestation, but one of the worst cases in the world is currently happening in Malaysia. Between 2000 and 2012, Malaysia had the biggest loss of rainforest of any other country in the world. Around 14% of its rainforest had been removed for plantation and logging. The biggest culprit is the oil palm business, which has caused around 47% of all the deforestation in the country. On average, Malaysia loses around 877,000 acres of land to deforestation, and it's only getting worse. As you can see from the map on the right over here, between 1950 up here in the top left of the map and 2020 down in the bottom right, Malaysia has lost more than half of its rainforest, much of which was due to the oil palm plantations like the one you see pictured here in the bottom left. So not only do poor farming practices remove rainforests, but they also lead to soil degradation, which can result in desertification. Now this map here was produced in a study in 2015 by H.K. Gibbs and J.M. Salmon. The study used data from various sources to estimate soil degradation across the globe. So let's take a look at this link down here and read the summary of this article. So as it says here, degraded lands have often been suggested as a solution to issues of land scarcity and as an ideal way to meet mounting global demand for the agricultural goods, but their location and condition are not well known. 4 approaches have been used to assess degraded land at the global scale: expert opinion, satellite observation, biophysical models, and taking inventory of abandoned agricultural lands. We review prominent databases and methodologies used to estimate the area of degraded land, translate these data into a common framework for comparison, and highlight reasons for discrepancies between the numbers. Global estimates of total degraded area vary from less than 1 billion hectares to 6 billion hectares, with equally wide disagreement in their spatial distribution. The risk of overestimating the availability, productive potential of these areas is severe, as it may divert attention from efforts to reduce food and agricultural waste or the demand for land-intensive commodities. So these guys produced this particular model here, and as you can tell, there are many areas across the world that have been affected by over-farming or overproduction of farmed goods and services, and poor farming techniques in general. And that soil degradation can often lead to vulnerability and desertification. Again, like I said before, poor farming practices and resource exploitation are destroying forests and plant life across the world, as it's stated here in this slide. This map shows land vulnerable to desertification around the world. Many of these regions are grasslands and have small seasonal rains. Poor farming practices and overconsumption of grasslands by cattle ranchers have led to the creation of deserts around the world from former lush grasslands. Now this photo shows the use of slash and burn practices on cattle farms. Now, the burning of grass helps to replenish the soil quickly, but can lead to long-term degradation of nutrients in the soil, causing farmers to move to other locations. Overt slash and burn practices result in the drying of soil. If an area already depends on small seasonal rains, one dry year can result in dried, cracked soil like this, like what's shown in this photo. Now, the use of chemical farming can also result in the poisoning of water tables and the destruction of aquatic life. We should be asking ourselves, if these farmers pictured here have to wear outfits like this to farm, should we really be eating this food? Now, these chemicals, not only do they seep into the food we eat, but they also kill some very important insects, as they are intended to do. Now, this has resulted in the destruction of bee habitats around the world. So we focus so much on CO2 emissions that we fail to investigate the real causes of environmental degradation. CO2 is an important and necessary gas for our environment, but other pollutants such as aluminum sulfate and sulfur dioxide lead to health problems and environmental destruction. Pollutants in the water, deforestation, and desertification are visible problems that are hardly addressed in the media. Now, I'll close with this slide because it's important for us to understand what is really impacting our environment and not get bogged down on other issues. We must pay attention to the true and harsh impacts that we have on the environment. And again, instead of focusing on CO2 directly, we should focus on these other issues at hand, which can easily be either reduced or eliminated. So just take some time over the next couple of days. Look over this video. If you have any questions about it, feel free to send me an email and let me know. And I hope you enjoyed this presentation. Have a great day.